This is my personal website, and as every web developer, I spend more time actually building the website than really writing articles or other content. I wanted to do a second version of this personal website. The first version uses mPages 1.0, and the second version was published a few times ago. So I want to upgrade and use mPages 2.0, which allows me to use mGraphQL with that. Thanks to Dylan Kearns for those two projects because they helped me a lot. So I want to use it with headless CMS, which is Dato CMS. Dato CMS allows me to have a nice interface to edit my content. For example, there is a field in Dato CMS which is really nice, I think, really neat. This is the structured text field, which allow you to write everything like a standard editor with Markdown. You can add some italic. Okay, and you can also add custom blocks. For example, here I've created a block that is called image that allows me to introduce inside my article an image. So, for example, let's choose this one and add a few options. It is fully customizable, so I can do whatever I want. When I request the content of this field through a GraphQL query, what I get is something like that. We can see that we have a schema that is of a DAS type and a document, which is a syntax tree containing all the article content. So today we will try to create a package to parse this kind of document. By chance, this is really well specified, so we will just use this document to know what we're doing.
So I've created an Helm package, which I'll call the Jigrina data CMS structured text. Maybe I will cross that. Okay. I have exposed only one module, which is structured text, which is right here, with two function decoder and two HTML that are exposed. I have another module which is types of my application, so I won't expose everything, but I will expose a few types. And I have some tests, so for now it's a default test of mtest. So if I try to compile them, should work. No, not exactly, because yeah, I think I forgot to import everything. Exactly, and it should work. Perfect. So I will try to do this using TDD. So TDD is well known for being test-driven development, so we will do that. But I will also do type-driven development. It will be, in fact, the first part of this video. So let's go to the types and maybe have a look at the specification. So as we can see, we have something that is a structured text with a document type root. Okay, so the document is always a node of type root. I think it's yeah, okay. So the document starts with a root node. So okay, and it can contain the following children node. So let's try to represent a node. Type node. It can be either, let's copy that, a paragraph, a heading, a list. Maybe I will rename that, a code, a block code, a single block, and a thematic break, or a thematic break. Okay, so we have those options. So this is a node. Root is a special node, so I'm not sure if I should include it inside the root. I think I will just try something there. Okay, so we have this kind of node, and we can see that we also have span and link. Okay, span, link, inline item. Maybe it's a little bigger. What do we have? Health, block, block, thematic break. I think we have everything. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm missing 2. Spam, link, paragraph, item link. I think I don't have item link. Okay. List item, I think. Yeah, okay. Perfect. Let's reorder them for later. So this is all the nodes that we can have inside the application. I can close that for now, it will be better. Okay, now what the document is saying is that the root node can only have those kinds of blocks. So let's define the type, which is root not child, and say that it can only be a paragraph, or so let's say root paragraph, which contain a paragraph, or root node. Okay. Yeah, I think what I will do before that is take all of these, copy them here. Okay. We will need to represent the content of those nodes, so let's say type node equals. Okay, let's say that we have something like that, so that we can take all those. It's a bit long. Okay, and say that it contains source. Okay. Maybe we won't need that, but let's keep it right now. Okay, so we have our node types, and now we can just create our root node, which is okay, which is, so I said okay. I do something weird. Okay, things that. So as we said, we can only have, where was it? I don't know. Okay, let's copy that again. So we can only have a paragraph, heading, list, and last item, code, block quote, block, so let's keep block, and thematic break. Okay, this is everything that we can have inside a root node. Okay, nice. Now let's continue. So for the root, we only have this and the children. So let's say that this is a root node and it contains a list of root child node. Root node that I will rename root child node. Okay. So let's see what a paragraph can contain. So a paragraph has a type paragraph, which is a constant, so we don't need to store it, and it can only have children. So paragraph node can have children. So a list of paragraph child node. So can, okay. Oh, I'm sorry, I'm on another screen. So the paragraph can only have those items. So let's create a paragraph child node, which is okay. So I forgot to add the paragraph. Okay, paragraph span, which contain a span node, or a link paragraph link, which contain a link node, or an item link, which contain a item link node, or inline item, which contain inline item node. Okay, so it's okay for the paragraph. Did I add list paragraph? Yeah, okay, perfect. What can we have? So a span. It's a text node, so it only contains a string value and maybe some marks. Okay. So the span node, which should be here, contains a value, which is a string, and a list of mark. What's the mark? Let's create that here. And it says that a mark can be strong, code, emphasis, underline, strike through, highlight. Okay, I think we have twice the code. No, it's okay. Okay, list of mark. So which is optional, so we can just have an empty array. Okay, let's go to the link. A link, it's yes, an hyperlink. So link node, where is it? Link node here, can contain. Okay, so type link URL. Okay, we can see later if you want to have a more precise type. So this is required. Children. Okay, children. Maybe add that as a second element. List and link child node that will create. So the children and meta. A list of tuple string. Okay. So this is it. Now we need to create the link child node right here. So we have, let's see, only span, okay. This is all we can have inside a link child node. Okay, maybe make it more readable. What can we have? Link, item link, so it's not similar to a link node, but instead of linking a portion of text, it links the document to another record present in the same .cms project. Okay, maybe we won't deal with the item link for now, so let's remove that. Item link node, we don't need that. It will be a bit harder, so yeah, it will be the same for block node. And inline item, so block node and inline item. Okay, so we're finished to represent the structured text document. So now we can try to create a decoder for that. Okay, so first we cannot have a structured text alone because it needs a list of children. Let's see if it still compiles. I will be surprised that it doesn't. No, it doesn't. Okay. Multiple code. Yeah, of course. I think we can remove this one. That is not needed anymore. Let's see. Yeah, perfect. So the tests are still running. Okay. Now we will need to start with some tests. Okay, so first test should decode an empty document. So this is the easiest case. Let's take an empty document right here. I think we can keep that on one line. Okay. Here we don't have children. So this is a basic document, and we are trying to parse it. So result equals we try to decode the string using our decoder. So first argument is the decoder. Okay, we need to import that, and second is the input. Let's remove those tests. So we want to check that the result. Okay, I think the expectation is the second one. Oh. So yeah, we should have the expectation right here. So I expect it to be structured text with an empty children, and here we're checking with the result. Why do I have an error? I'm not sure. Oh yeah, I forgot the parentheses. So let's see. It compiles. So two things. I will first launch it in watch mode because it will be easier. And after that, I will check that the test can fail. So let's say here, if I have fail, sorry, it fails. Perfect. So our test does something. Okay. Now we can write the second test. So sorry about that. Should reject a document with invalid schema type. Here I want to test that if this is not correct, we will have an error. Let's say that we have a typo right here. We need to check that it will reject. So here it should be an error. I think it will be on the failed schema and the failure. Let's see. So failure string, and we need a value. Okay. So let's say that if result of error schema failure. We need a reason right here. So in this case, I think it's this one. Yeah. Expect that. Okay. No, not this one. Oh, I don't remember. I think it's pass maybe. Expect dot pass. Okay. So here the reason should be a wrong schema type. Expect pass, and every other case so unknown or invalid. That should be a schema type error. Okay, let's try that. So we have two tests and one is not passing. Okay, so let's try to implement that. Let's go to the decoder, and we want to be sure that there is. So let's try to create a helper function. Constant string decoder. that will check that the string is properly as a proper value. So we don't need to return anything with this decoder because it's only something that will check as a constant. And what we will do is decode the string and then compare it so we need an expected value, so right here, and we will just check that the expected value is the same as the string value, and return decode.succeed, else we can decode not fail wrong. Okay, so we can check that. Now what we will do is check the field schema. It should be diced. To give more context. So we need that. No, okay. Let's keep it that way for now. We'll see later if wrong constant value. Okay. And then what we need is taken and then our map, maybe. So we receive an empty tuple and we just return succeed. We don't need to decode that succeed. Okay, I guess it's pretty nice. And now the test is failing because the error is not the proper one. Okay, let's go to the test. I think this is what we need to change. Perfect. So now we have okay, that is failing. Perfect. I won't test the root type here because I'll do that later. Maybe we should go on something more valuable. So let's try to parse, what should we parse? What is the simplest one? Let's see. Maybe the thematic break node, it's the simplest, I think. Okay, so should decode a document with a thematic break node. Okay, so let's say that we only have type thematic, how is it spelled? Thematic break. Okay, just that. And we should have a thematic break. A root thematic break. Yeah. Okay, perfect. So this fails, of course, but we have another failing. Can find a thematic node break variant. No, okay, only one failed. Okay, so what we need now is to parse the children. So, okay, so we need to have a new decoder, which is root child and decoder. So decode that field children. which is a decode.list of root China decoder. Perfect. So we need a decoder of root China. Okay. We can create that. What's the matter? Decoder list root China. Oh, okay. My bad. We can just do root thematic break node. So we can just do that, and it should pass the test. Okay, this one is correct. Why is this one failing? Because I get a list of children, and now I need to map that to a structured text. Oh, okay, yeah, of course, I forgot to receive the value right here, so it's okay. So we have two failed tests. Why? Because, oh yeah, of course. Or maybe not. Okay, it's trying to find the children. Okay, yeah, of course. Because we need to do that, in fact. So we will call that the schema decoder. Or not. No. My bad. Yeah, in fact, we need to go to at document and children to decode the root. Okay, perfect. So now it works. Let's try to add another type. Which one is the second difficult? Don't need node right here. Let's see. Maybe inside the root node we have paragraph, list, code, block quote. Maybe let's start with the heading. Heading channel, yeah, it has some children. Maybe code, yeah, code doesn't have children. Okay, so let's decode the code node. So right here in the test with a code. Okay, type code. What should we have? This will be more clear. Okay, so inside the code, we should have type code. Where is it? Type code. Okay, I think we have code containing the code. Some random code, and we can have yeah, not worry about that. I think it's too mandatory. Yeah, because we have the language and the highlight. So let's try a simple code. Root code. So we need a code node which contains code which is this. Language should be nothing, and highlight should be equals empty list. Okay, I have an error. I don't know where. I think I forgot to close something. maybe right here. Yeah, better. Okay, so now we're trying to have a code node, so okay. And we have one failed test, so yeah, pretty different, of course. So we will need to be a little bit smarter right here. And we will first decode the field type, which will be a string. And then, so we have the type string. And let's do a case on that. So if it's a thematic break, we can return that, which is a success. Okay, and if it's something else, it could not fail. Unknown type, unknown node time, root node type. Okay, we can add the type string here to have a more precise error. Okay, so we should still have one failing test. Yes, exactly. So now we can implement the new type, which is code, and we can have a code node decoder that we will create right here. Decoder is so a decoder of code node. I can generate that, I think. No. Okay, so code node decoder is basically tree field. So code node. The first one is code, which is a string. The second one is optional, so this is the language that is a string, or I think there is optional or something like that. No, one off, maybe. Okay, yeah, exactly what I need. So because that maybe the so the field language because that maybe a string. This is not good. Why? Oh yeah. Okay. Few ways to handle that. Code language. And the third one was highlight, if I remember correctly, which gives us code language highlight equals highlight. And I need to close that. Okay, and I need a third one, which is the highlight, which was a list of tuple. But why is it code highlight 0 base every line number to highlight? Okay, so it's just a list of integers. Okay, so now we have a code node decoder, and we can, maybe it will be more readable if I map first code root code node. Root code, yeah, better. It doesn't compile. Can find a code node variant. Where is that? Code node, yeah, I didn't import it. It doesn't work. Why? Three paragraph. Feature grant. And then language. Okay, it doesn't find language, so I think it should be decoded maybe of everything. Okay, yeah, it's the same right here. Here I will just either take the field, either take a list. Okay. I think it should work. Yeah, perfect. So we've implemented two cases right now, which is pretty nice. Let's start something a little bit more complex, maybe with a paragraph decoder. So next test is, okay, let's copy this one. I think I should decode a document with a paragraph. Okay. So now we need to have a paragraph. Let's see what does a paragraph contain. So a paragraph should contain only children. Okay, perfect. Children. Okay, so let's try a paragraph right now. So we need, yes, an empty paragraph. Let's start easy. We can keep that in one line. And what we're expecting is a paragraph with 0 children. It's here. Okay, we can just keep that on one line. Here too. Root paragraph, okay, should contain a paragraph node with an empty array. We need to import the paragraph node. Okay, perfect. We should have a failing test. Yes, exactly. So let's continue to implement. So here, let's add paragraph node. Paragraph node decoder. Okay. The paragraph node decoder should return a paragraph node. And basically all we are doing is decoding the field children for paragraph child decoder, and it's a list. Okay. Children list. Yes, and I need to map that. Paragraph node. Paragraph child node decoder. So it's a decoder of paragraph child node. Paragraph child node, which I need to import. And it's basically where to decode. Okay. I will do and send. And do basically the same thing than before. Okay. So it can be all of those, but we haven't done any of them, so I think, yeah, for now, we will just return and return the type string. Oh, okay, yeah, better. I think we're okay. No, it's not compiling, so yeah, paragraph null. I don't know why the plugin is failing on this. Okay, so it fails because it should unknown root node type paragraph. Why is that? Paragraph node. Okay, it's my bad. Perfect. So we've implemented the paragraph type. So thank you for watching me. If you want to see the next step, I will record another video for the next step of this package. If you liked it, please let a like, and you can subscribe to my channel if you want to see more content about Elm and the front-end web development. Thank you.